Early AI functioned primarily as text predictors. Today's models evolved into autonomous execution engines that book flights, manage calendars, and write code without constant supervision. This rapid evolution has created a dilemma. We are currently bombarded with 12 distinct technical concepts, from deep research to model context protocols, and attempting to implement all of them at once leads to operational paralysis. Mapping these 12 terms into operational stacks provides a clear framework for implementation. We can group them based on their specific functional utility. This framework organizes the landscape into 3 lanes: the executors for action, the anchors for transparency, and the connectors for integration. The executors column consists of tools designed to take action and complete complex tasks autonomously. The anchors column focuses on tools that provide transparency, factual grounding, and strict data security. The connectors represents the tools built to integrate these AI capabilities with your existing software and legacy databases. Managing the 2026 landscape requires identifying your specific operational friction and investing heavily in the single stack that addresses it. Modern automation relies on digital tasks being chained together without manual intervention. With agents and computer use, the AI takes direct control of your software. It navigates your desktop, clicks buttons, and completes forms just like a human user. Vibe coding further scales this output by allowing anyone to build functional software simply by describing the desired result in plain English. These capabilities are managed through workflows, an orchestration layer that links autonomous actions into end-to-end business processes. The primary outcome of the executor stack is the total automation of repetitive digital labor. This matrix evaluates automation benefits against setup requirements. For executors, setup time is minimal, but the risk of cascading errors is significant. Granting AI direct control removes human oversight. A flawed instruction can lead the system to execute dozens of mistakes autonomously before you notice. Deploying executor tools is a direct trade of oversight for operational speed. The quality of your initial instructions becomes your single point of failure. For enterprise organizations where data security and absolute accuracy are mandatory, the operational focus shifts heavily to the anchors. Systems like RAG and reasoning force the AI to retrieve verified internal data and process logic step by step before it generates an answer. Deep research extends this by acting as an investigator, scouring datasets to synthesize a verifiable truth rather than just predicting a text response. Open-weight models provide the highest level of security, allowing you to run a powerful AI locally so your proprietary data never leaves your internal network. On the matrix, the anchors provide high fidelity and security. However, they cause a massive spike in required IT infrastructure and total setup time. RAG requires pristine internal data hygiene, and open-weight models demand expensive hardware to run efficiently. The anchors serve as a corporate insurance policy. You are paying a premium in setup time and compute power to guarantee zero hallucinations and zero data leaks. Many older legacy systems and software applications cannot naturally communicate with new AI models, creating a massive bottleneck for integration. MCP, or the Model Context Protocol, solves this as a universal standard that safely connects AI models to your existing databases and apps. Multimodal AI adds another layer of integration, allowing systems to process text, images, and video simultaneously for more complex interactions. Features like memory transform the AI from a transactional tool into a partner that retains your past interactions and workflow preferences. While connectors offer seamless integration, the matrix highlights a high barrier to entry under technical skill. Implementing connectors requires mastering context engineering. You must learn the technical art of structuring inputs and rules to guide the AI safely. Connectors turn AI into embedded infrastructure, but users will face significant frustration if they attempt to implement them without first mastering prompt architecture. Navigating the year 2026 is about adopting the specific lane that matches your constraints and goals. This decision tree begins with your primary objective. If you are a solo optimizer who needs to scale your personal output without writing code, you follow the left path. Your stack is the executors and memory. Focus on vibe coding and computer use for immediate efficiency, and ignore complex backend setups. If you are an enterprise decision maker requiring absolute accuracy and data privacy, move down the center. You must dedicate your resources to the anchors. Master RAG and open-weight deployments to secure your data before exploring autonomous agents. If you are a builder or developer responsible for integrating AI into existing software, follow the right path. Your focus is the connectors. Mastering MCP and AI workflows allows you to build the infrastructure that links legacy code to modern models. Aligning these specific AI tools replaces the current technical chaos we face with a clear, directed path forward. The most effective strategy for 2026 is to look past the general hype and adopt only the specific tools that solve your immediate friction. Pick your stack and start building.